So in this video, I'm going to be showing you how the trigonometry of special angles were proven. All right. So I have there are three major special angles we are going to be focusing on. That is 30 degree, 45 degree, and 60 degree. But in this particular proof, I'll do the 45 degree proof. Then after which, I'll also do the 30 by 60 proof. So the first one I want to do is what 45 degree by 45 degree, by 90 degree proof. So for us to be able to achieve this, we are going to be using an isosceles right triangle. So let me draw an isosceles right triangle. So this, pardon me. So we're going to be drawing an isosceles right triangle of side x unit. Yeah. So in that case, if it's an isosceles triangle, this is what 45 degree here. This is also what 45 degree here, and this is what 90 degree. So if these and these are 45 degree, it implies that they are the base angle. So the length of the side here and here will be the same, x and x. So basically, for us to be able to prove this, we need the hypotenuse. If you check the previous video I did under this for the sides of where we compare angles, I've determined the hypotenuse. But because this is a separate proof, I have to show it. So let me call this side A, let me call this B, and let me call this C. So from Pythagorean theorem, we need the hypotenuse. That's the side facing the right, angle. So the hypotenuse have to be squared first. The Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the square of the other two sides. So we can say that AC square is equal to what? Is equal to what? AB square, right, plus what? BC what square. So we have what? AC square is equal to what? AB square, that is what? X square, plus BC square, that is what? X square. So we have what? AC square is equal to what? 2 what? X square. X square plus X square, 2X square. So AC, right, will now be what? Square root of what? 2X square. And that will give us square root of 2 times square root of what? X square. This cancels this. So that will give us what? X root what? X root 2. So this side basically is what? X root what? 2. Now, having gotten all the three sides, we are now going to be using the SOHCAHTOA, sorry for that, to determine their special angle. So that implies that if you don't want to do a case whereby you'll be comparing two triangles that are of special angles, then you can use your SOHCAHTOA. That is if you are able to master those special angles and you still get the same result like I got in the videos. So now, if you have not watched the video on how to use SOHCAHTOA, please, you can quickly pause this video and quickly check that video on my playlist together. So we are going to be using SOHCAHTOA. So in this case, we are focusing on 45 and 45. So if you are using 45, so let's take this as our reference angle. So this is what we are going to be using as our reference angle all through this particular SOHCAHTOA. So if this is my reference angle, definitely this is my opposite, right? And the side facing the right angle is the hypotenuse. So this is my hypotenuse. And definitely this will be the adjacent in this case, okay? So let's now determine SO. So in this case implies what? Sine what? Theta, which is opposite, right, over what? Hypotenuse. So our theta in this case is 45 degree. So this implies that we can say that sine what? 45 what degree will now be equal to what? What is the opposite? That is x over what? Hypotenuse. That is what? X root 2. So x over x root 2, x cancel x. That is 1 over what? Root 2. So we need to rationalize this. If we rationalize this, we multiply the numerator and denominator by root 2. So times what? Root 2 over what? Root 2. So this will give us 1 times root 2, that is root 2, over root 2 times root 2, that is root 4, which is 2. So sine 45 degree will give us what? Root 2 over 2. So please note this. All right. Then that is that about that. Then let's move on to cos 45. So cos 45, that is CA. CA means what? Cos what? Theta, which is equal to what? Adjacent over what? Hypotenuse. So we can say that what cos what 45 degree will now be equal to what is adjacent. These are reference angle, don't forget. That is still what x over hypotenuse. That is what x root 2. So this will still the same thing as this cancel this. So we still have what 1 over root 2. So if you rationalize it, that's times root 2 over root 2. And that will give us root what 2 over what over 2. So this and this, sine 45 and cos 45 are the same, all right? Then let's move on to the last one. That is what tan 45. So let me use, so for tan 45, that is TOA. TOA is got to what tan theta, which is what opposite over adjacent. So we can say that what tan 45 degree, right, will now be equal to what? So what is our opposite? That is what x over what is our what adjacent. That is what x. So x divided by x is equal to what 1. So this implies that tan 45 degree is equal to 1. So if I summarize everything, I can summarily say, so therefore, I can say therefore tan what 45 degree. Did I say tan 45? Let me start with sine, okay? Sine 45 degree is got to what cos what 45 what degree, which is got to what root 2 over 2. Then we have what tan 45 degree, which is got to 1. All right, so that is that about that. I want to believe this video has helped someone. Please don't forget to subscribe, like, and share this video. The more you share it, the more you like, the more you subscribe, you encourage me to produce more. So in the next video, I'm going to be showing the case of what 30 by 60 by 90. See you in the next video. Thank you. Bye.